Hi everyone. Hi students. Today at the same day I'm making these all lectures. Okay. So another two important type of problems from trigonometry I'm going to solve now. I'm making 20 minutes, 17 minutes lecture so that it will be easy for you to watch. Okay. So next we are going to have another problem related to the same trigonometry. Little important problems these are. That is, if secant theta plus tan theta, it is given p, then they're asking, then show that sin theta is equal to p square minus 1 divided by p square plus 1. Okay, so this is they're asking here. So here we have to use the properties of identities. Basically you can say identities of this trigonometry, that is 1 plus tan square theta, we know that it is secant square theta. Okay, so from this we can take this tan square on the left hand side, so it becomes minus tan square theta, so we get it as secant square theta minus tan square theta is equal to 1, right? Now this secant square theta minus tan square theta, it is nothing but we can write it as a square minus b square, that is a plus b into a minus b. So we get secant theta plus tan theta is nothing but a plus b into a minus b, that is secant theta minus tan theta is equal to 1. Now what they have given in the problem, that is secant theta plus tan theta is equal to p. So we are going to substitute here, secant theta plus tan theta is p into secant theta minus tan theta is equal to 1. Now we bring this complete secant theta minus tan theta on the right hand side, we get in the denominator and of the right hand side. So 1 by, or it will be further typical, we bring this p on the right hand side of the denominator. So we get secant theta minus tan theta is equal to 1 by p. Okay, so this is you have to do, that is keep secant theta minus tan theta on the left hand side, bring the p on the right hand side, we get 1 by p. Okay, so we what they have given is secant theta plus tan theta is equal to p. So here we have two equations. One is secant theta minus tan theta equal to 1 by p, another is secant theta plus tan theta equal to p. If you add these two equations here plus, so here secant theta plus secant theta, we get it as 2 secant theta plus tan theta minus tan theta, we get it as 0. Okay, and here we get p plus 1 plus p plus 1 by p, this we get. So this is 2 secant theta is equal to, what we get here is 2 secant theta is equal to p plus 1 by p. So if you take the LCM here, we get it as, p is the LCM, we get it as p square plus 1. P square plus 1 we got it as p square plus 1 by p, we got it as 2 secant theta, right? This is we got, so we can take it as equation number 1. And now we have further to continue here. What they have given is secant theta plus tan theta is equal to p, and what we got is secant theta minus tan theta is equal to 1 by p. Earlier what we have done in this is we have added. Now what we are going to do, we are going to subtract. So here minus, this minus is going to become plus. So secant theta plus secant theta and minus secant theta will get cancelled. Plus 2 tan theta plus 2 tan theta, we get 2 tan theta, and here we have minus. So we get p minus 1 by p. Okay, here minus, this minus we got it as plus, here we have plus earlier, so we got it as minus. Now if you take the LCM on the right hand side, we get p, and we get it as p square minus 1 is equal to 2 tan theta. So this we can take it as equation number 2. Now if you take the ratio of this equation number 2 and equation number 1, we get the required answer. That is, equation number 1 is what? Equation number 1, we have it as p square plus 1 by p is equal to 2 secant theta. This equation number 1 we have. Now if you take the ratio of these two, we get the required answer. Required ratio, what they have asked in the problem? P square minus 1. So we divide equation 2 by equation 1. So what we get? Equation 2 by equation 1, p square minus 1 by p whole divided by p square plus 1 divided by p. So this is equal to what? P square minus 1 by p is, we have 2 tan theta divided by, here we have 2 secant theta. Okay, this 2 and 2 will get cancelled here. This p and this p will get cancelled. Now what we left with is p square minus 1 divided by p square plus 1 is equal to tan theta divided by secant theta. So this we get tan theta divided by secant theta. So here you can tan theta we can write it as sine by cos. Tan theta we can write it as sine by cos theta. So cos theta comes in the denominator and here we have secant theta. Now can anybody tell what happens to the denominator? Here we have sine theta divided by cos into secant. These two will get cancelled because secant theta is nothing but 1 by cos. So those two will get cancelled. We get in the denominator as sine theta. This is what they have asked to prove. Okay. So this is our required answer. So that is p square minus 1 divided by p square plus 1 is equal to sine theta. This is what they have asked in the question. Okay. Another problem similar to this we are going to have. They give it as cosecant theta plus cot theta is equal to k, and the last show that or prove that cos theta is equal to k square minus 1 by k square plus 1. It is similar to the earlier problem. What is the difference here we have is the identity which we are going to use here is 1 plus cot square theta is equal to cosecant square theta, similar to the earlier one. And here we are going to take this cot square theta on the right hand side. 1 is equal to cosecant square theta minus cot square theta. So this we get here. So this is a very important identity similar to earlier one. Okay, cosecant square theta minus cot square theta equal to 1. So this you can write it as a plus b into a minus b. So cosecant theta plus cot theta which they have given is equal to k into cosecant theta minus cot theta. This total overall RH is equal to 1. This cosecant theta plus cot theta, it is given as k into cosecant theta minus cot theta is equal to 1. Now we are going to bring this k on the right hand side as we have done earlier, and we left on the left hand side, that is cosecant theta minus cot theta is equal to 1 by k. Okay, so now same way we are going to solve here. That is this equation 1 we can take. Okay, and the given, what is given, cosecant theta plus cot theta is equal to k. This we can take it as equation number 2, and we are going to do the addition of 1 and 2. Addition of 1 and 2. So here plus, already plus, here plus. Okay, so when we add these two, plus cot theta minus cot theta will get cancelled, and cosecant theta plus cosecant theta we get it as 2 cosecant theta, that is equal to k plus 1 by k. So if you do the simplification here, cosecant theta is equal to k LCM, we get it as k square plus 1. K square plus 1. This we take it as equation number 3. So here we have done the addition of 1 plus 2 equations. So we got it as 2 cosecant theta equal to k plus 1 by k. Another one we are going to do is the subtraction of these two. We are going to do subtracting the equation 1 and 2. Another step is subtracting the equation 1 and 2. Okay, so when we do the subtraction, what we have is cosecant theta plus cot theta. This is equation number 2 which we have taken is equal to k, and cosecant theta minus cot theta, this is equation number 1 which we have taken. So now if you subtract, so here we get minus, this minus becomes plus, and here you get minus. So plus cosecant theta minus cosecant theta will get cancelled. We get 2 cot theta is equal to k minus 1 by k. I'm explaining little faster because already we have done similar to this. LCM is k, and here k by 1 we get it as k square minus 1. That is 2 cot theta is equal to k square minus 1 plus k. So this we can take it as equation number 4. Now we are going to take the ratio of these two equation 3 and 4. What they have asked is show that it is k square minus 1 by k square plus 1 equal to cos theta. So we do here dividing 4 by 3. So we do get k square minus 1 by k divided by k square plus 1 by k. Okay, so k square minus 1 by k is nothing but 2 cot theta divided by k square plus 1 by k is nothing but equation 3, that is 2 cosecant theta. So this 2 will get cancelled here, this k will get cancelled here, and this we get it as k square minus 1 by k square plus 1. So cot theta is nothing but cos theta divided by sin theta. Already here we have cosecant theta. Cosecant theta. So we know that sin theta into cosecant theta is equal to 1. So that denominator we get it as 1. So cos theta by 1, it is nothing but cos theta. Okay. This is what they have asked. Show that k square minus 1 by k square plus 1 is equal to cos theta. Thank you very much for watching.